The second colligative property is elevation in boiling point. Boiling point का बढ़ जाना. अब क्वेश्चन है कि boiling point किसी सॉल्यूशन का क्यों बढ़ेगा. boiling point का बढ़ना के पीछे जो रीज़न है वो है प्रेजेंस ऑफ नॉन वोलेटाइल सॉल्यूट. नॉन वोलेटाइल सॉल्यूट का प्रेजेंट होना. एक सिंपल सी एग्जांपल हम लोग ले सकते हैं. वी हैव टू स्टोव्स इन अ गैस. And what we have done is we have taken simply water in one of the stove, and in the another one we have added some solute. Let us take, we have added some sugar to it. Now just check this out, which one is going to boil first. So obviously water will boil first, and the water containing the sugar, which is a non-volatile solute, will take more time to boil. So it means that the boiling point of a solvent, of a solution containing a non-volatile solute, is always more than the boiling point of pure solvent. Now this is what we have written here, that elevation in boiling point is boiling point of solution containing non-volatile solute minus boiling point of pure solvent, and we have mathematically represented it as delta TB is equal to TB minus delta TB is equal to TB minus TB naught. This is elevation in boiling point is equal to boiling point of solution minus boiling point of pure solvent. Now let us work it graphically here. So we have taken solvent, we have taken three curves. Very first curve is for solvent. This curve is for solvent. Now we have considered two solutions. Solution 1 is more volatile than solution 2. That's why solution 1 is above solution 2. Solvent has maximum vapor pressure. We have plotted this graph against vapor pressure against the temperature, boiling point. Now solvent has maximum vapor pressure, so we have taken it up. We have considered solution 1 to be more volatile than solution number 2. This line represents atmospheric pressure. It represents atmospheric pressure. Now solvent कब boil होगा? When will the solvent boil? A solution boil when its vapor pressure is equal to the atmospheric pressure. तो solvent की जब vapor pressure इस atmospheric pressure के बराबर हो जाएगी at point A. So the solvent will boil at point A. What is the temperature here? Temperature is T0. So the boiling point for solvent is T0. Now the solution 1 boils at this point B, because the vapor pressure of solution is equal to atmospheric pressure as point B. The temperature corresponding here is T1. So T1 is boiling point for solution 2. Similarly T2 is the boiling point for solution number 2. Now the vapor pressure for solvent is P0. What is the vapor pressure for solution 1? तो भाई solution 1 की vapor pressure हम लोग यहाँ से निकाल लेते हैं. This is P1, this is solvent की P0, solution 1 की P1. What is the vapor pressure of solution 2? This is P2. Now just check this out. अगर solution dilute है, obviously हम लोग dilute solution पर ही काम कर रहे हैं. Dilute, if we are talking about a dilute solution, आप check करो, ये जो curves है ना BD and CE, इनको straight line consider किया जाता है if the solution is dilute. These are considered, BD and C are considered as straight lines. अब आप यहाँ पे similarity of triangle को लगा लो. Just put similarity of triangle here in triangle ACE. So the ratio of AC by AB is equal to AE by AD. AC by AB is equal to AE by AD. Now what is AC mathematically? This is AC. So what is AC? T2 minus T0. This is what we have written here. What is AB? AB ये part है. So what is AB? T1 minus T0. What is AE? AE is this part. P0 minus P2. What is AD? This part. P0 minus P1. So left hand side we have temperature difference and right hand side we have pressure difference. So temperature difference is equal to pressure difference. Graphically we have proved it. Now we have learned in RLVP, this is from RLVP, relative lowering in vapor pressure, that the relative lowering in vapor pressure is equal to mole fraction of the solute XB. Now we have removed this constant vapor pressure of solvent and we have introduced here a proportionality sign. Now this xb can be written as nb by na plus nb, and we have removed this proportionality sign using another constant k. If this solution is dilute, there is no need to write NB here. अगर solution dilute है, so the amount of solute is very less. So let us remove NB from here. The equation क्या बनेगा? Delta P is equal to K. NB को मैंने तोड़ दिया, WB by MB. NA can be written as WA by MA, तो ऊपर चला गया. Now K is a constant and molar mass of solvent is another constant. So K multiplied by MA is written as KB, a new constant. So delta P is equal to delta T. We have already written over here. We have proved it graphically. तो delta P के जगह पे delta T हम लिख सकते हैं. We have written B as subscript because we are dealing with boiling point. जब freezing point पे काम करेंगे, depression in freezing point, तो F वहाँ पे introduce करना होगा. So the working formula is delta TB is equal to KB times M. This is molality, this is molality. भाई ये KB क्या है? KB को हम कहते हैं मोलर इलिवेशन कांस्टेंट और इब्यूलियोस्कोपिक कांस्टेंट. अगर इसको डिफाइन करना और डेफिनेशन ऑफ KB, तो आप मोलालिटी को 1 ले लो. इफ मोलालिटी इज 1, देन KB इज इक्वल टू डेल्टा TB. तो भाई ये है क्या? इट इज द एलिवेशन इन बॉइलिंग पॉइंट ऑफ 1 मोलर सॉल्यूशन. ये एलिवेशन इन बॉइलिंग पॉइंट है वैसे सॉल्यूशन की जिसकी मोलालिटी 1 होती है. अगर मैं इसके यूनिट को निकालना चाहूँ तो KB इज इक्वल टू डेल्टा TB बाई M. डेल्टा TB का मतलब है केल्विन या फिर डिग्री सेल्सियस, और मोलालिटी तो आप जानते ही हो. सो यूनिट इसकी क्या होगी? केल्विन किलोग्राम पर मोल और डिग्री सेल्सियस किलोग्राम पर मोल. And now KB is mathematically determined by Beckmann's and Cortriel's method. These are the two methods for determination of KB. Beckmann's method and Cortriel's method. वहां से KB को एक्सपेरिमेंटली ये कैलकुलेट किया गया है R गैस कांस्टेंट, TB नॉट स्क्वायर इनटू MA by 1000, डेल्टा H enthalpy of vaporization. Now enthalpy of vaporization by MA is latent heat of vaporization. इसको हम यहाँ पे इंट्रोड्यूस कर देते हैं. latent heat of vaporization is basically taken in calorie per gram और joule per gram. R की वैल्यू 2 कैलोरी पर मोल पर केल्विन होती है जब आप कैलोरीज पे काम कर रहे हो, और अगर आप जब जूल पे काम करोगे तो इसकी वैल्यू क्या हो जाएगी? 8.314 जूल पर केल्विन पर मोल.